Why we do floor planning, I have already discussed with the analogy of that building of home or house, that this is the partitioning. So the one bigger circuit is partitioned into smaller circuits, and then they are actually placed. They are actually placed. A placed and floor planning, those two are very similar, go hands in hand, but they are actually having a slight difference. The difference between the floor planning and placement is, in case of floor planning, we don't have the actual sizes, the actual shapes of the blocks, but for placement it is physically placed. Okay, it is actually placed. So in case of floor planning, suppose one bedroom, you know the area of the bedroom is 150 square feet, but you don't know that 150 square feet is 15 by 10 or 12 by 13 or somewhat like that, or is it of square shape or rectangular shape, and that rectangular shape is rotated or something else. So in the case of floor planning stage, you are in that domain only. In case of placement, you know that okay, this block is these blocks should be placed as a square, because I have already come through this partitioning and floor planning algorithms decided that this block should be a square one, then only it will give us the minimum maximum routability, minimum area, etc, etc. Okay, that is the routing. Routing is the, I was telling you that the pin assignment is actually placing the doors and windows in the house, the IO ports type kind of things. That is, we are placing the pins, okay, IC pins, and routing is just the connectivity, the interconnection between the blocks, the partitioned blocks. So routing will be covered later. Today I will discuss this floor planning. Now I am discussing. So in case of floor planning, the basic concept is inputs to a floor planning problem is a set of blocks, right? Fixed or flexible by partition. With those are the set of blocks, and they can be fixed or flexible as well. But for in case of placement, they should be fixed. Okay. Now pin locations of fixed blocks. Okay, and a net list. Obviously, the partition blocks are as well another net list. An objective of floor planning is minimizing the area. Okay, the yield should be less. Reducing the wear length. Wear length means what? That is the mean cut. The interconnection wears should be less. That kitchen and the dining we are placing side by side because we are going through that corridor the most. So those ones are the critical nets, which will communicate the more in the circuit. And maximize routability, that means routing should be maximized, and determine shapes or of flexible blocks shapes. Floor plan design. See, this is one floor plan. The partition blocks are actually floor planned, and these see, these kind of spacing is actually given for the routing. This kind of spacing between the blocks are given for the routing, and these spaces are actually known as channel definition. Okay, providing these spaces. Okay, I was talking about that. The rectangular shape is placed like this or that. That is rotation. These are very basic things of floor planning design. This is very important. This slide is very important. Floor planning terminology. What are the terminology? See, rectangular dissection. Subdivision of a given rectangle by a finite, this hash actually used for the number, okay. Finite number of horizontal and vertical line segments into a finite number of non-overlapping rectangles. Slicing structure. Actually, in floor planning, we have two structure. One is slicing structure, another is non-slicing structure. I'm just explaining it from this figure. The non-slicing floor plan is slicing floor plan. See, the slicing floor plan, this is vertically sliced. After that, the horizontal division. After this horizontal, this vertical, horizontal, vertical, right? But in case of this non-slicing, see, these vertical and these vertical lines are not coincide each other. Okay. Next, this block is not within the same line with these two blocks, right? 2, 6, and 7 are not actually carrying one same horizontal edge. So this kind of floor plan is known as non-slicing floor plan. What do you think? Which kind of floor planning technique is better? Slicing one or non-slicing one? One is better. Okay, why slicing one is better? Because we can represent this slicing floor plan with a binary tree. In the data structure, we know that binary tree, the childs are there. Okay, right child and left child. যেরকম তোমাদের দেখবে structure binary kind of tree representation is possible for slicing floor plan, but it is not possible for this non-slicing floor plan. So obviously, if we have one defined data structure for representation for one floor plan, so we will go for that only. No, we are not going for this non-slicing one. So obviously, this one is the better one. Next, very good. Next, that is a slicing tree, a binary tree where each internal node represents a vertical cut line or horizontal cut line and each leaf a basic rectangle. So that vertical line is, and here another horizontal line, so H. That H is actually having two child, 1 and 2, so 2 and 1. Sorry. And that H is again having, this H is again having one vertical line. Okay. Yes. This H is having 3 and again another H. This one. This H is having another vertical line. Dekho, V. Skewed slicing tree, the definition of skewed slicing tree is one in which no node and its right child are the same.